Hi, student friends. Good morning to all. I welcome you all in this fluid mechanics practical session. So today we are going to perform the practical number 6, that is calibration of V notch or rectangular notch. As per syllabus, this is practical number 6. Calibration of V notch and rectangular notch. So write down their title in your notebook. Calibration of V notch and rectangular notch. That is the title. Write down the aim to determine the coefficient of discharge
सर स्क्रीन दिसत नाही.
एक मिनिट. Screen practical number 6. Yes, is it visible now?
Yes, sir.
Write to the aim to determine coefficient of discharge of V notch and rectangular notch. Ravi, एवढा उशीर? So in the theory we have learned there are various types of notches. We can classify the notches on various categories, various types, right? So one of the classification is classification based upon the shape of the orifice, and there we have classified the not orifice, about the notch and wears. We can classify the notches and wear based upon the shape, and these classifications are V notch, rectangular notch, trapezoidal notch. These are the classification. And what is the V notch or triangular notch? It has the shape of the triangular V shape notch is there, so that is called as the V notch. And if the rectangular shape is there, then we call it as a rectangular notch. So triangular notch or V shape opening in the tank of the side of the tank or small channel in such a way that liquid surface in the channel or tank is below the top edge of the opening. So that is the definition we have learned. So V notch is the notch having triangular shape of the opening. Triangular notch provided in the channel carrying water is shown in figure like this. Right. So we are going to determine what is the coefficient of discharge. जसं आपण याच्या अगोदरच्या प्रॅक्टिकल मध्ये we have determined the coefficient of discharge for the venturimeter. Then we have determined the coefficient of discharge for the orifice. Similarly, in this practical, we are going to determine the coefficient of discharge for the notch. Okay, so this is the aim here, and V notch, in V notch, this is called as the crest or apex of the notch. If the trapezoidal notch is there, then we call it as a crest. Okay, and here we call it is apex. Okay, so let us see the setup of this. This is the experimental setup. Here some tank is there, measuring tank is there. Then this is the what you can say channel is there. On the large tilting plume, the arrangement is like this. This is the plate venturi. What you can notch is there, V-shaped notch, and here we take the readings. So this is the procedure that is well. You can read it one by one afterwards. Observations and observation tables. So this experiment we are going to perform on the tilting plume, and what are the specifications of these tilting plumes are there. Area of the tank, angle of the V notch, and initial reading. So you can note it down in your notebook and prepare the observation table like this. Okay, do it fast. Area of tank. Rather here you can write area of the measuring tank. Area of measuring tank. Capital A is equal to 0.4 by 1 meter is equal to 0.4 meter square. Angle of V notch, theta is equal to 40 degree. Initial reading, height of crest 70 mm. So I have taken this observation and put here on the slide. So you can also take this observation by yourself when we are going to do the perform the practical. Height of the crest or height of the apex here 70 mm, that is 0.07 meter. Prepare the table. 7 columns are there. Serial number, point gauge reading, in point gauge reading there are 2 columns, initial and final. Next column, head of the water over the notch, head of water over the notch, capital H. Then volume of water collected in meter cube, time required in seconds, time required T in second, and Q actual meter cube per second. So likewise, we have to retake the 3-4 readings, and then we do the average of the Q actual, that CD. Is this observation and observation table is over? Dalega. Next, calculations. What are the calculations that we need to do, perform in this particular practical? Q actual is equal to Q actual is equal to area into A into H, small h divided by T. What is small h? What is small h?
Water level print distance.
Rise of water level in the tank, measuring tank. Okay. या ठिकाणी आपण मेन्शन केलेलं कुठं नाही केलेलं. So here we can mention small h is equal to rise of water level in the measuring tank. T is equal to time required to rise the water. T is equal to time required to rise the water by h meter, small h meter. And what is capital A? It is the area of tank, cross section area of the tank. Observation में तुम्हें लिखले area of measuring tank. Second calculation. What is the formula to find the discharge by using V notch or triangular notch? 8 by 15 tan theta by 2 into under root 2z into h raised to 5 by 2, where theta is angle of notch, h is equal to head of water over the notch, and third, calculation of discharge. CD is equal to Q actual divided by Q theoretical. So only 3 formulas are there. 3 observations are there, and next one, result table. Serial number, Q actual, Q theoretical, CD and average CD. Okay, and last conclusion. So same thing you can do with the rectangular notch also. If time permits, we will change that V notch and we will place the rectangular notch. We will take the observations. So for the rectangular notch also, we have to prepare the table like this, observation table. Okay, and then here in observation, we will require the length of the notch or the width of that notch. Length, you can call it the length of the notch. Okay, so that we have to we have to measure there, and then calculation will be same. Q theoretical formula for the rectangular notch will be, what is the formula? 2 by 3 B into or L, 2 by 3 into L into under root of 2z into h raised to 3 by 2. So that formula we will use for finding the Q theoretical. Okay, and result table will be same. And here in conclusion, one more conclusion you can add: the average value of coefficient discharge for the rectangular notches. Okay, so afterwards you can do that. If time permits, if we are going to perform that practical by using the rectangular notch also, and then you can add that tables and results. Okay, so this was the practical. Very small practical is this, actually very simple. So to perform this practical, we have to go to the concrete technology lab, because that apparatus is there. One apparatus here, small apparatus is here also, but it is having some problem there. So we will perform the practical on the tilting plume. So you will have the actual feel of channel and that notch on the tilting plume. Okay. So here dictation of this particular, we are going to stop here and we are going to perform the actual practical there. Okay. So I am going to stop this session here. Be logged in only, be sign in. So just I'm stopping this recording here. So we will go there and then we will perform the practicals. Okay. So till that, be there, sign in. Okay.